Very good morning, ladies and gentlemen. Welcome to this webinar on innovation and productivity in construction, presented to you by SCAL. It's actually common knowledge that the construction sector, we have a dubious reputation of being a laggard when it comes to productivity, compared with other sectors, like manufacturing, for example. Well, one may argue that the parameters used to measure productivity should be different for different sectors, but nonetheless, the reality is that we do need to find new ways for construction that will have lesser reliance on manpower, either local foreign or local and foreign manpower. Hence, in recent years, there has been concerted push by the government and in industry for adoption of technology, for mechanization, automation, digitalization, and innovative solutions. These are further driven by the Construction Industry Transformation Map, or ITM, when it was launched in 2017. The results are a bit encouraging so far. In the Economic Survey of Singapore for 2019, the Ministry of Trade and Industry has reported that the construction industry experienced productivity growth in real value add per actual hour worked, higher than the other overall average in the Singapore economy. In fact, the value added per worker in the construction industry in Singapore rose from minus 1.7 in 2016 to 1.4% in 2017, 0.9% in 2018, and 2.1% in 2019. So it's steadily moving up. But of course, the events unfolding with COVID-19 pandemic this year, it will no doubt have a dampener on this momentum. But it's said that productivity drive is like a marathon without a finishing line. So in fact, the current COVID-19 crisis bear testament that there is an even greater need for the use of technology in construction, as the foreign manpower crunch bites even deeper. As the industry champion and the leader, SCAL has an active program on productivity and technology to help members keep in touch with the latest trends in development, build capacity, build capabilities for the adoption of new technology, and to raise awareness of the various government grants and programs to adopt productivity solutions in their companies. One of our key initiatives is the SCAL Productivity and Innovation Awards, or PIA. We started this in 2016. PIA is our annual competition to encourage out-of-the-box thinking by employees in construction firms to raise productivity through innovation. The PIA recognizes efforts by construction companies that embark on innovative projects that will improve construction methods and processes, and that will result in greater efficiency and productivity. More importantly, PIA encourages the involvement of employees in the construction firm to participate in innovative projects where they themselves generate ideas for improvements in their respective workplaces. Since it started, we have very good traction. We attract about 30 entries from 15 to 25 companies a year. And every year, 10 entries are shortlisted to be assessed by a panel of judges from government and industry stakeholders to select the top 3 winners of gold, silver, and bronze medals. I would like to take this opportunity to thank all our members, participants, supporting organizations, and respective agencies for the strong support for SCAL PIA. Again, we are unfortunate that we could not organize this year's competition due to COVID-19, but we will surely be back. We hope that we will continue to receive your continuing support for the awards next year. This morning, we are very proud to introduce 2 innovative projects from our member companies who were the gold and silver award winners for 2019. I'd like to thank our speakers for taking time to share the innovative ideas today. And importantly, the thought processes and the challenges behind them. I think it's important to understand how some of these ideas are generated from the ground itself. Firstly, we'll hear from our Silver Award winner, Mr. Yong from Quack Civil Engineering, will share with us the innovative project Pool and Rail method for box culvert construction under roads. This will be followed by our Gold Award winner for PIA 2019, Mr. Balaji Mohanraj from HSL Construction will tell us about the Nautilus Trident. It's a very interesting project, and I commend you to listen to that. So at the end of each presentation, we have a short Q&A. You may pose your questions, as the moderator has said, and we'll take as many as we can. Without further ado, I now hand you over to Mr. Yong for his presentation. Mr. Tan, please go ahead. Thank you.
Okay, let me do an introduction. We are actually the Silver Award recipient for PIA 2019, and we are from Quack Civil Engineering. We are a A1 contractor under the BCA register. So for this morning presentation, we will be going through on one of our project, which is the upgrading of Terminal 2 drain and road expansion works along the Airport Boulevard at Changi Airport. So for this project, we are actually constructing a box culvert across Airport Boulevard. So this is the plan view of the box culvert construction. We are supposed to construct a box culvert along city bound and airport bound. So this is the length of the box culvert, which is about 51,100 mm across, going towards, the direction is going towards airport and upcoming Jewel during that time. So the first initial method was using the consultant proposed method, which is the conventional way to construct. In this design, it consists of a lower part precast box culvert followed by a upper part box culvert installation. The top of the culvert is actually higher than the existing road level for this design. So by using this conventional method, we are supposed to do the installation of temporary decking, followed by the removal of decking for excavation, and then proceed with the excavation to required level. Then the delivery of the lower portion of the box culvert, followed by backfilling, and then we proceed with the installation of the top section of the box culvert. Next, we will proceed with the placing of the back decking system to open up lane for traffic, and then laying of premix over the decking. And then we follow by removal of decking and premix to continue work and backfill to the approach slab level. During this portion, it is the most intense and time consuming due to the opening and closing of the traffic to allow for the next day operations. So this is part of our constraint for this project. So on the last portion, after the completion will be the removal of the king post and steel plate, followed by the installation of the approach slab, and then the reinstatement works, which consists of the milling, patching to proposed level. Okay, so some of the challenges that we are facing, we have 4 main challenges if we are using this conventional method to construct the box culvert across along this airport boulevard. First will be the repetition works, which we require to remove and reinstall back premix and decking, and follow, as we need to follow the permissible lane closure and lane open timing to maintain the traffic flow. Next will be the allowable lane closure timing, which is restricted, given to us. For day works, we are only allowed for 10 a.m. to 4 p.m. for work, and for night works, we are only allowed for 1 a.m. to 5 a.m. So due to all these restrictions, there is a lot of repetition works that required during our construction works. Next will be, if you look at the layout plan, this drain alignment is actually not perpendicular to the existing lane. So by using this method, we are affecting not just one lane in order to construct one box culvert. By constructing one box culvert, we actually require us to close more than 2 or 3 lanes will be affected. And the last point will be the emergency lane opening. We actually have to open up the lane within 30 minutes in the case whereby there's emergency. So removal of machineries and reinstatement work for traffic flow before the lane opening will be a big challenge to us as well if we continue to use this conventional method. So we have plotted up a graph to analyze our challenges. So in terms of method, if we proceed to use the conventional way, the impact will be due to the small work window allowed by our client. And then in terms of environmental, we are only allowed to close 2 lanes at any one time. So this method will not be feasible for us. In terms of machinery and manpower, it will be a challenge to us also, as using this method will require us to do a lot of repeated steps for the opening and closing and the reinstatement work, as we need to reinstate the top layer before we are able to open up to the traffic. So all in all, if we proceed with this method, there will be impact to the existing traffic and also operations going to the Changi Airport and the upcoming Jewel during that time. So we analyze the root cause. We input 4 main points mentioned. The root cause will be restricted work windows given by our client, as this Airport Boulevard along this road is a very important stretch going towards the airport. And for these works there, we are only able to close up to 2 lanes. And due to the repetition works, road closure is also a big challenge to us. And we also subject to airport emergency. We need to evacuate within 30 minutes for not to affect the traffic flow. So all these 4 main points is a main challenge for us, and the undesired outcomes will be delay to the upcoming Jewel opening during that time, and we will be facing LD from client and poor productivity. So we have come up with a solution, which is to abort the conventional method and avoidance of above ground works and explore underground method. So what we have come up with an innovative method, which is the pull and rail method. By using this method, we have no restriction to the 24/7 operations. So we are able to proceed with the excavation works and the installation of precast, but not being affected by the restricted work windows and closure timing. So as mentioned, no need road closure, don't need repeated works, and not subjected to airport emergencies. And the final outcomes will be on-time delivery and satisfactory from client, and increase in productivity through innovations. So let us go on to our innovative method. So this is what we have come up with, which is the using this pull and rail sliding method for our full cell box covered. The previous method was actually a lower portion and upper portion precast box covered, but this time round, instead we are using a full cell box covered, which also help us increase our productivity. So the first step will be the installation of the king post and steel plate, followed by number 2 will be the precast box covered, delivery of the box covered to site to the receiving shaft, and at the bottom below the ground, under the ground, we will be doing the installation of the pulling jack and preparing for the footing for the sliding rail. The next few slides we will explain on how these things works. So the box covered segment is a 6700 mm by 2400 mm. Each piece of precast box covered is estimated to be 32 ton. So similarly, this box covered, the top of the cover is actually higher than the existing road level. So our temporary works is actually much higher than the existing road level. So this is the diagram. First of all, we will proceed with the installation of the king post and steel plate, which is the earth retaining structure prior to our construction works. This portion will be progressively from lane 5, lane 4, lane 3, progressively to the other side of the road. After the installation of the king post and steel plate, we will proceed on with the installation of the deck beam and steel plate and runner beam at the top. Once we complete this portion, we are able to do our excavation under the ground and also to proceed with the installation of the box covered, not affecting the existing traffic flow anymore. So once the box cover is delivered to the site, it will be placed down from the receiving shaft and then being pulled in using the sliding rail and pulling jack. So once it's complete, we will proceed with the removal of the steel plate decking and then complete with the reinstatement works. So let us do a comparison of the consultant proposed method and our Q&Q innovative method. So as mentioned, the 4 main points, by using the conventional method, there will be repeated steps. But by using our method, the decking and premix is only installed once and there's no repeated methods as the opening of decking is no longer required. By using the conventional method, we actually have to open up and closing even for the excavation and for the placing of the precast segment. But by using this innovative method, after we install the decking, we no longer have to open up the decking as we can do our works underground. So next point will be the lane closure timing. If we are using the conventional method, but by using this innovative method, works is carried out beneath the road and no lane closing timing is we are not restricted by the lane closure timing anymore during the excavation and the installation of the box covered. For drain alignment, which is not perpendicular to the lane of the road, box cover installation not to overcross lane with traffic next to it. But by using our innovative method, the installation of box cover fit within the lane width is not required because we are doing our works underground. So for point number 4, similarly, we are not restricted as we will not be affecting the ongoing live traffic flow. In terms of productivity comparison, we will take a look at point number 5 and number 6, which has major help by using this innovative method. For the excavation work, if we are using the conventional method, we require 60 days to complete. But if we are using this innovative method, we are talking about 37 days. We are able to complete the whole stretch of excavation works. And for the installation of precast segment, if we are using the conventional method, it's talking about 36 days, but innovative method, we are able to complete it within 18 days. Also to take note, for the installation of the precast segment, if we use the conventional method, the precast segment actually consists of the top portion and the bottom portion, and the connection part also requires time for us to do the connection and grouting works. But by using this innovative method, we are pulling a full cell box covered, so there is no joint in between the top and bottom section. So overall, we are talking about productivity saving of 37.8% in terms of productivity for man hours. Next, we will go on to effort saving. Similarly, for point number 5 and 6, if we are using the conventional method, we have to open up and close back the decking, and then to do the reinstatement work every day for us to proceed with the excavation and the installation of precast segment. But by using this pull and rail method, this portion, excavation and installation of precast segment, don't require us to do an opening and closing of the top decking. So this portion does not require us to do the reinstatement work. Therefore, the effort saving for this portion, we do not require any effort saving, any effort here. So in terms of saving, we are talking about 27.91% based on our study. So let us go on to some actual photographs of the innovative method. First, we proceed with the survey setting out, followed by trial hole excavation and cable detection by LEW. As this drain alignment is not perpendicular and slightly slanted, in alignment and precision has to be very accurate for us to install the I-beam. So next, we will proceed with the installation of the king post, proceed with the steel plate installation, and backfilling work and compaction. After we complete the installation of the decking, after we finish the installation of the king post, we will proceed with the decking. So delivery of the decking, then we'll install it. So as you can see, the decking is actually much higher than the existing road level because the top cover is actually higher. So once we proceed, this portion will be progressively lane by lane. So after we finish one lane, we'll go on to the next lane to do the installation of the decking. So after the installation of decking, the excavation works and the installation of the precast box cover will be underground. So this portion will not be affected by the existing live traffic flow at the top. So excavation, first we proceed with the excavation, shifting of the excavated soil to the shaft and remover. So this portion, once we complete, we'll proceed with the casting of the slab and preparation of the pulling rail. So this picture will show the installation of the sliding rail underground. Once we complete the sliding rail and the sliding slab, we'll proceed with the installation of the pulling jack. This strand will be connected to the box cover, and box cover will be entering from the receiving shaft and then be placed on the rail and being pulled in segment by segment. So from here you can see the first diagram. The precast box cover is being delivered to the site and then being hoisted down to the receiving shaft. Once the precast box culvert is below under the ground, we will proceed with the alignment. On this portion, the alignment of the two rail and the placing of the box culvert on the rail has to be very accurate and precise. And the pulling speed of the rail for the two sides using the jack has to be very accurate, and the timing has to be very precise as well. So after the box cover is being placed on the rail, we will proceed with the connection of the jack and strain to the precast box culvert, and progressively each piece of box culvert segment will be put in. So after we complete the excavation work and the delivery and installation of box culvert, the remaining works will be the reinstatement works, which is the removal of temporary toppings and removal of temporary decking, followed by the removal of king posts. Once we complete the removal of king posts, we proceed with the compaction works and delivery of the precast approach slab. Once we complete, we will complete the final stage, which is the asphalt laying and compaction, followed by the lane marking and ready for the usage. So during our construction of this precast box culvert, various agencies like the BCA also visited the site to take a look at our innovative method for this construction of box culvert across the airport boulevard. So this is the completed photographs after the reinstatement works. So this is the final slide. We'll go on to in terms of tangible benefits, man hours, we are talking about a saving of 147,000. And in terms of asphalt saving, we are talking about 28,000. But the major item will be the LD avoidance, which is we're estimating about 30 days times 6,000 per day, which is 180,000. Total estimate, we are talking about 355,000 of savings by using this innovative method. In terms of intangible benefits, this method has helped us to enhance our corporate values and mindset change as we are able to embrace innovations and enhance engineering competency, and it's extremely high operational worth as we are able to also use this similar method to others upcoming project. And in terms of environmental sustainability, we are able to minimize the resource consumption and maximize resource reuse. We are able to reuse the asphalt. And in terms of improved safety records, we are able to eliminate the risk to workers due to road closure and tight work window, as our workers are able to work under the existing road. So we eliminate some of the risks that the workers will face when they work during the road closure. So potential success of future project tender, as we are able to manage to complete the project in time, so client satisfaction. And this method is also being formulated into our company capability for new method for underground works for upcoming future project. And it's also a spin-off whereby we can share this method with similar industry. So I've come to the end of my presentation, and I thank all my participants for taking part in today's webinar. Yeah, thank you. I pass on back to the moderator.
Thank you very much, Yong. Excellent project, and I think it's an incredible example of innovation processes to overcome engineering challenges, clients' requirements, and productivity improvement. Also, the impact on the traffic to and from Changi Airport, and I believe at that time It was also near the opening of the jewel, so the traffic must have been quite heavy. We have two questions, and I'm not sure whether you have answered them in your presentation. It says, Mr. Tan, this question is from Po Yong Tan. Mr. Tan, your productivity increased 37%, which is good. What is the overall cost comparison like? And the second one from Alex Lay, did you guys do a cost comparison? I think you might have already answered that in your presentation.
Okay, in terms of cost comparison, we are only it's actually an estimate, because we understand that by using this conventional method, definitely the project will be delayed because of this restricted time and the restricted working hours for us to complete the project. We are only taking an estimate LD time of 30 days. So we are able to come up with the savings, which is 355,000. But we may actually, if we are using this conventional method, this construction of box cover may actually exceed more than 30 days of LD, which in the overall cost for this project may actually exceed. Yeah.
Okay, good. We actually do have another question from Hong Hui Tong. And the question is, after installation, do you remove the decking pin posts and refilling, or just leave the items there?
Okay, after the installation of the decking king post, we will proceed with the construction underground, which is the excavation and the installation of precast box culvert. After this process, we actually remove the decking and the king post and then proceed with the backfilling works. The decking and the king post is actually the earth retaining structures. After we complete the works, we need to remove.
Okay. Thank you very much. I think what we'll do is we will proceed with our second presentation, and it's the Gold Award winner of PIA 2019. Can I just now hand you over to Mr. Balaji Mohanraj from Mohanraj, sorry, from HSL Construction. Please proceed, Mr. Mohanraj.
Thank you. Good morning, everyone. First of all, I thank the organizers and SCAL for inviting us to present our Nautilus Trident here in SCAL PIA 2020. Last year, we received Gold Award for our innovative Nautilus Trident. I would like to take this opportunity to introduce our company HSL. Our company HSL established in 1994 and incorporated in Southeast Asian countries. We have over 1,500 employees with more than 10 different nationalities, and our regional presence is over 6 countries. HSL is a regional infrastructure construction company. We also help bring the electricity and clean water to the communities in the marine infrastructure and supports the oil and petrochemical industries. Our regional business footprint in these various countries like India, Myanmar, Vietnam, Malaysia, Indonesia. Our HQ is based on Singapore. So these are the 3 major industrial segments that we are looking at. Land and sea transport. So in that we do all the ports, jetties, roads and bridges, canals and waterways, bulk terminal management as well. In industrial plants and energy power, we do all the process plants, refineries, tank farms, plant maintenance, and also the power plants. In industrial plants and water environment, wastewater treatment plants, renewable energy, incineration, waste to energy, potable water plants. First, I want to explain the schematic layout of typical seawater intake outfall system. Where this intake outfall system being used? So almost all the power plants with gas-fired turbines, coal-fired turbines, desalination plants, cooling water for power stations, firefighting, industrial use, feed water for steam turbines, nuclear power system, all these industries, they have the intake-outfall system. What are the various types of intake and outfall systems? So intake and outfall can be in various ways. One is through the box culverts, one is through the reinforced concrete pipes, another one is GRP pipes, and high density HDPE pipes we call, and the last is the open channel method. So these are the three types majorly in the intake outfall system. As I explained, box culvert line, you can see in the first picture, using the box culvert, we can transfer the water for the cooling water systems. Second is the GRP, RCCP, and HDPE, either of these pipelines in the second picture. And third is the open intake or open outfall. So in this picture, you are seeing the open outfall system. For box culvert, we have an example project in for box culvert, which is Jimma coal-fired power plant. So we work under the ISAI Corporation. So this project is completed on 2018. So here you can see the intake method is through the open channel, which is the rock bund system, and the outfall is the concrete box culvert. Here we have two numbers of box culvert line of about 1.75 kilometer. We use the conventional type of installation using the crane barges, conventional cranes to install the box culverts. These box culverts weighing about 300 tons, and here the number of box culverts also close to 300 numbers. Next is an example for the open channel, which is the discharge system, which we did in Manjung Power Plant, Malaysia. So under the client Samsung CNT, so the year completed is 2016. The system adopted is outfall open discharge. Here the next example is the pipelines. So in this pipeline system, this example is from the PRI CCGT under Samsung CNT. The year completed is 2014. So here two numbers of GRP pipeline of 3.2 diameter of about 500 meter long. Here the outfall system is the open discharge system. Okay, we have in all these power plant project, we have faced some difficulties. So and also some challenges what we faced. So first I would like to explain about the challenges we faced in Jimma power plant. So in Jimma power plant, we did the conventional bedding. So for the pipe installation or the box culvert installation, we need the seabed to be level properly, and it should be bed using either the stones or the gravels. So in this method, we use the conventional type of bedding, which is using the crane barge. And you can see the disadvantages of this system is turbidity effect and inaccuracy, and also high wastage of materials. After we do the bedding, we need to do the level. So in order to place the pipeline or the culverts in position, we need to make sure the seabed to be level properly. So initial days we use divers to go and do the leveling manually. So this one is more time consuming, and it is the precision also very less, and also it exposed to high risk for divers. After we do the seabed leveling, we need to install the pipelines or box culverts in place. In this particular power plant project, we, as I mentioned, this one is 300-ton culvert. So we use the heavy lifting equipment, which is the conventional type of cranes for installing the box culverts. We use 4 numbers of tugboats because the barge is bigger in size, because our capacity, our load of the culvert is big, so that we need the big crane barges to come and do the installation. So we used 4 numbers of tugs, and also marine safety hazard because of the big sizes of the barges and the tugboats, and which is deeper in draft. So we need to have that jetty, which is also to be deeper. So we need more dredging for the temporary jetty for parking these crane barges near to the shoreline. Okay, so we decided it's the time to put our heads together, and we have to bring some innovative solution to construct this kind of box culvert and also heavy lifting objects. So our main objective is we bring out some idea. Our main objective of this idea is to improve, which is reducing the manpower, reducing the equipment usage, and also minimizing the time. Second is to develop the things, which is using the louvers for bedding. Later I show you some pictures and the videos, and also by using the multi screws levelers, and also to develop the GPS positioning in order to make the accuracy in positioning, and also to have multi-beam surveying system to predict the seabed, to analyze the seabed by using this system. Third, it should be environmental friendly. So to being environmental friendly, we need to reduce the fuel consumption first. Then to implement the solar panels. Then fourth thing is our objective, which is the advanced safety systems. So to minimize the diverse deployment, to have the live monitoring surveying system, to real-time monitoring system, and also minimize the tug movements. As I mentioned, we need to have 4 tugboats to handle the bigger barges, and to eliminate the poor diver visibility. Normally in offshore working, we always face this problem, which is the poor visibility of the divers during the installation of pipelines or culverts. So this is the timeline for our new innovative trident. So April 2018, we completed our Jimma project. May 2018, we did the brainstorming. We wanted to have a brainstorming session to find out a new innovative solution to do all this box culvert installation. In June 2018, we awarded the next project, which is Malacca project. In July 2018, design of the innovative trident in place. In August 2018, we started our fabrication and shipbuilding activities. In Jan 2019, we successfully launched our trident. In February 2019, we mobilized our trident to the work site, and also we started our work. Okay, let us see the trident barges. The trident barges are totally 3 numbers. One is the bedding barge, second is the leveling barge, and third is the heavy lifting barge. So we see the bedding barge first and its advantages. So this is the trident bedding barge. We have louver gates opened by hydraulic system, supports the uniformity in bedding. So you can see in the picture, there is a difference between single gate opening system and also using the louvers. So by using the louvers, we already minimize the high and low spots during bedding. Second is the multi-beam echo sounder surveying system, which is synchronized with the hydraulic power system, which increase the accuracy while doing the bedding. You can see the advantage of the louvers in this. On the right top side, you can see the louvers working system. This is the model that we demonstrated before we go for the innovative trident. You can see the evenness during the bedding. So the same system is applicable for this bedding batch. So we plot the bedding grids in our layout, and by using the echo sounding system, we measure the quantities to put inside each boxes, and the bedding batch will be, and the bedding frame will be lowered down. Second is the trident leveling batch. So after we do bedding, we need to do the leveling, because in order to minimize the ups and downs in the bedding, we use the leveling to do the level. So this one also having the continuous improvement. Initially we used blade kind of leveling system. After that we innovated, we continuously modified our system in order to increase the accuracy and also increase the efficiency. On March 2019, we go for the single screw leveling system. That also will be followed by the triple screw leveling system, which is on June 2019. So you can see the 4 adjustable legs in the leveling batch. This one is in order to adjust the level required design levels. We can adjust the 4 legs by using the hydraulic system, which can be operated from the batch. I can show you one more video of how this leveler is functioning. Third is the Brighton gantry batch. So this is the batch that I'm talking about, which can be used for the heavy lifting activities. There are many advantages in these batches and also many innovative things that we incorporated in this batch. First, the gantry crane batch of 550 tons safe work load with highly automated systems. Second is the rail cart of 500 tons. You can see the rail cart, which is the yellow color. So this one is to transfer the load to the described location of the batch. So you can place 4 or 5 numbers of cargo on your deck, and this rail cart system, which will be used for carrying these loads towards the crane. Third is the counterweight rail cart system. In olden days, we use the pumps, manual pumps and water for ballasting the barges to make the barges level properly during loading, during lifting. Now we have this counterweight rail cart system, which is instantaneous. So based on the level of the barge, based on the stability of the barge, this counterweight is moved towards the opposite direction to maintain the barge stability. So these are the other applications of Nautilus gantry batch, which is GB in short form. So you can see box culverts, then we can install intake headers, and we can install even the pile caps for the bridges. We can use also can be used for installing the beams, and it can be used for installing the artificial coral reefs, which we use for our in our Singapore projects. So we also made the graphical presentation for comparing all these environmental cost efficiency of this Nautilus Triton with reference to the conventional projects. Fuel consumption. So here you can see for the fuel consumption for the Triton barges versus the conventional systems. Almost it decreased more than half of the fuel consumption for doing this activity when compared to the conventional systems. So this comparison we made comparing our Jimma project versus our Malacca project. Second is the number of equipments to be used. For bedding, we have 7 numbers of equipments, and whereas for the conventional system, these are the numbers showing how many numbers of equipments like tugboats, like barges to be used to doing this activity. So overall, it reduced about 20 to 25% of equipments for this Triton method. Manpower. Since the usage of divers is minimized, so here you can see the numbers of manpower to be used for this Triton. Almost 35% of manpower be decreased by using this Triton. While for the productivity wise, for the bedding activity, we reduce almost half of the time doing the 100-meter square of bedding area, because in the conventional system we use the manual cranes to doing this bedding activity, whereas for this bedding batch it will be more faster. For the leveling, we use the divers in the conventional system. Here we use the mechanized system and the robotic equipments to do the underwater leveling. Third is the heavy lifting. So here also our time we reduced almost more than half for installing the culverts, since the barge movement is very easier compared to the conventional type of cranes. Here is our cost comparison. When compared to the conventional type, almost like 35 to 40% of cost we can reduce in overall by using manpower, less equipment, and also less fuel. Here is the graph showing between our conventional system and also the Triton system. So this is the sequence normally we used to follow. You can see the number 1 batch is doing the bedding, number 2 batch is doing the leveling. After that we install the pipelines or the culverts. For this particular project we use the culverts. I will show you a video. First is the bedding batch. This is how we do the loading of materials. By using the material batch alongside with the bedding batch, we load the materials. Based on our survey calculation, each boxes how many numbers of how much quantity need to be put, we already determined earlier. Based on that, we fill in the boxes. After that, we lower the frame as shown in the video, and we uninstall, we dump all the bedding materials in the trench. After we doing the bedding, we position our leveling batch based on the GPS positioning system to the exact location, and we do the leveling afterwards. This is our third batch, the gantry batch. The draft of this batch is less than 2.5 meters, so it can navigate to the shallow water so easily. And you can see very less numbers of torque is needed to handle this batch when compared to the conventional type of crane batches.
I'm sorry, Balaji. Could you finish in about 2 minutes? Thank you. I'm sorry, Balaji. Can you finish in 2 minutes? Thank you.
Okay, sure. So these are some of the working pictures of our Triton badges. These are the references. For inquiries, you can contact us for these badges. These badges currently in Malaysia, so it can be work anywhere. Thank you.
Thank you very much, Mr. Balaji. I think this is another clear example where innovative ideas can be generated internally and overcoming the elements. Today we have heard really two excellent examples, the gold and silver winners of PIA 2019. There are many others, and I think our purpose here is to show the industry what is possible and how innovative ideas and projects can be developed in-house with very good results. I know there are a couple of questions, but I'm afraid we have run out of time. And I think once again I'd like to thank our speakers for the sharing. I do sincerely hope that they have inspired you to think about your own innovative ideas. Do go into the SCAL website to learn more about other projects that have been submitted for the PIA awards over the last few years. And of course, you can always contact those companies, to share some of the thoughts. Do keep a lookout for our announcement for the SCAL PIA next year, and we do hope that it will spur greater productivity in our companies. Last but not least, I'd like to thank the organizers of BuildTech Asia Digital Series for giving us this airtime. So without further ado, I would like to call this session to an end. Again, thank you everyone. Thank you all for attending. Goodbye and stay safe. Thank you.